Hello and welcome everyone to an hour of .NET debugging. This is going to be fun. It's been a long time since I presented .NET debugging actually. But the things that we're going to be looking at, well, starts good. Let's see. Okay, let's debug that for a moment. Let's see. Slideshow, don't use presenter view. Okay. Oh, okay. Yay. Thanks for debugging that for me. Whoa. Okay, so we're starting over. Welcome to an hour of .NET debugging. We're going to be debugging those kind of issues that you can't really step-by-step debug. So essentially crashes, performance issues, and memory leaks. And when you can't step-by-step debug, you have to resort to something else. And that something else is generally either profiling, which we'll be looking at a little bit in the performance section, but also mostly memory dumps. Do any of you use memory dumps? Okay, quite a few. So for those of you who don't know, memory dumps come in two flavors. They're either user mode dumps or kernel mode dumps. So user mode dump is a snapshot of a process at a given time and everything that it, like all the memory that it addresses. So it's kind of like taking a picture or stopping at a breakpoint. You can see whatever is there right now, but you can't move forward, you can't move backward, but you can investigate traces of what has happened already. And if we look at a memory dump, we're going to look at it in WinDBG first. I'm not actually going to use WinDBG all that much throughout the presentation, but just for those cases where you actually want to go really deep down, WinDBG is a great tool. So WinDBG comes with the debugging tools for Windows or the drivers SDK, so really pretty much any Windows SDK. So you probably already have it on your machine, even if you've never seen it before. And what we're going to do is we're going to go ahead and open up a crash dump that I gathered earlier. And I put a few commands here on the right-hand side, or left-hand side. Can you see them in the back? Perfect. So this is just so that you can follow along while I'm going through what you can see in a memory dump. So a memory dump has a few things when you start it up. Like it tells you how long the process has been up, how long the system has been up. So in this case, the process has been up for 25 seconds, and the system has been up for two hours. It also tells us that the memory dump was taken with something called procdump, which is a tool for gathering dumps. And it tells us that we threw a CLR exception, so we crashed due to an unhandled .NET exception. And then some things that we can do are, for example, ~KB, where tilde means thread, star means all, so all threads, run the command KB, which means show stack. So what we're doing here is we're basically displaying all the stacks of all the threads in the process. And if you disregard this piece, which is just addresses of some parameters in, this piece on the right-hand side should look pretty familiar to you if you've ever debugged anything in Visual Studio or any other tool. So this way we can kind of investigate and see what the process is doing. We'll see a few things that are specific to .NET processes, like the finalizer thread, which is the thread that goes through and calls all your destructors. So if you have a class in .NET that has a destructor, that will get called on that particular thread. That means that, for example, since there is only one, that if you're blocking the finalized thread, you're going to cause a problem. You're going to cause a memory leak because nothing else can get released. And also, if you throw an exception in a destructor, it will crash the process. And we have a few other threads. So this thread has some weird function names on it. Presentation core something something, not readable. And this is because WinDBG doesn't understand .NET. It's just a native debugger. This thread actually happened to be the thread that caused the crash. So we're kind of interested in what went on there. And in order to be able to read .NET code, you have to load in an extension. So we're going to load in something called SOS. And we do that by calling load by SOS CLR, which means that we're going to load in the extension CLR, or SOS, from the same place where it found CLR.dll, which is the main DLL in the .NET framework. So if we go in and look at Shane, just to see the extensions we have, we'll see that it loads it from the framework, which is important because it tells you that you will always have SOS. You don't have to download it from anywhere else, as long as you have the framework installed. So we have that. So now we can run commands like CLR stack. And it will always throw an exception, in this case on the first one, but ignore that. And now we'll see something that looks a lot more like what we're used to. So a .NET function, like next button on click, calls into a view model, like a function called go to another on a view model, and that in turn throws an argument out of range exception. So right now, we're already done investigating this crash, essentially. We found out that this particular stack caused a crash and threw an argument out of range exception, and we'll look at the code, and we're done. But we could do more things. So we could, for example, run dump stack objects, or for short DSO, and that will give us the objects on the stack. So pretty much like when you're stopped in WinDBG, you'll see all the objects on the stack. In this case, we'll see 5 argument out of range exceptions. That seems kind of like a bit excessive, but it turns out it is just the same one. We can see that because it has the same address, but it shows up on multiple frames in the stack, like multiple stack frames, and therefore it shows up multiple times on the stack. But we can go ahead and dump this out with dump obj. It does that automatically when you click on it, and it will show you the actual object, so you can go ahead and investigate it and find out what's in it. It also tells us a little bit more about the object, like it's 92 bytes big. These 92 bytes is just for the structure of this object, not for the member variables. If we want to know the actual size of the object itself and all the member variables, we'll run something called obj size. And we'll find out that including the member variables, it's 6,000 bytes. And then we can go in and dump out like the message, for example, and find out the actual string of the message. So why would you want to write out, for example, the obj size? Well, it's useful for if you want to go through an ASP.NET dump and find out how much is in cache, then you would do obj size on the cache object, and you will find everything that's in cache and so on. Sometimes you might want to know why an object is not being garbage collected. And in that case, you just take the address of the object, and you'll run a command called gcroot, and that will tell you basically the roots of the object, so why it's still sticking around. So this particular string is a member variable of an argument out of range exception. We already knew that. And it's part of like a try-catch on a thread. So that is why it's sticking around. So as long as that's alive, it will be there, and when that's dead, then it can be garbage collected. And then we can find a few more things, like, so these are all things that you would find in Visual Studio if you stopped at that exception. But we'll find a few more things like lm, which lists out the modules in the process. So this will list any DLLs or EXEs in the process. And a useful thing with this is, for example, if you click on this, which happens to be the name of the process, we can find out the version numbers of the DLLs and stuff like that. So if you get a memory dump of a customer's machine, you'll know if they're running the same version that you're running, or if they have a hotfix, or what have you. And finally, when you're debugging memory issues, you might want to look at the heap. So what's on like all the .NET objects in the process. So you'll run, for example, eheap-gc, which will give you information about here that we have 3 megs of .NET objects. Super small, but it was only up for 25 seconds. And then you can also run things like dump heap.stat, and this is kind of where it gets a little bit, interesting, because now you can enumerate every single object on the heap. So every single object that's in the process, which means that you can go in a process, and you don't actually have to own this process. You can be running, for example, Office, take a memory dump, and you can go in and look at every single string that is in the process Office, including if they have API keys to that is stored in there to do API calls. So be a bit careful if you don't encrypt your API keys and stuff like that, because you can find out a lot from memory dumps if you're interested. So this is like a little bit about what you can find out from dumps. So where did we go? So you can find out threads, call stack, stack objects, modules like the DLLs and EXEs, and the .NET heap, and basically anything that's in the process. So how would you gather these memory dumps? Well, there are a couple of different ways, and the easiest way is to use Task Manager. Right-click and choose Create User Dump. And this is useful if you have a process that's hanging or a process that has a memory leak. Then you just go in and do this, and it's a perfectly valid memory dump. And the only few caveats on this is that if you run a 32-bit process on a 64-bit system, it will gather a 64-bit dump, which is a bit harder to debug. And if you want to debug something like a crash, Task Manager doesn't allow you to wait for a crash to happen and then create a memory dump. But then you can use procdump. Procdump is a free tool from sysinternals, and the best thing about it is that it's super lightweight. So it's just a small exe. You can take it, copy it over to your server, and run it there. And you don't have to install it, so you don't have to get permissions to do big installs or whatever. You can just run it there, and it's actually fairly fast and even capturing super large dumps. And the thing about it is that you can also configure it to do certain things, like over here you can see -H means that it will wait for a window to stop responding. And -C means that it will wait for the CPU to go up, in this case over 90%. Or -E means that it will wait for the process to crash. And then you have debug diag, which is both a crash gatherer and an analyzer. So this was something that I worked on for, well, quite a long time ago, when I got tired of writing CLR stack and all these WinDBG sessions, and I decided that automation was king, and I wanted to just have a machine do it for me instead. And I basically automated myself out of a job, but that's cool. But debug diag is pretty powerful both for capturing dumps and for analyzing dumps. So for capturing dumps, it has a lot of nice UI things for setting up, like gather a dump at this specific exception, or whenever this perf counter hits this value, or whatever it might be. And it's also good for native leaks, which we won't talk about here, but if you have a native leak, that's good. And for analyzing memory dumps, we've seen how you can do it in WinDBG, but you can also do it in debug diag, and we'll use that a lot. It has a lot of analysis scripts already written. You can write your own analysis scripts if you have a specific issue that happens over and over again, and you just want to verify that the 104th dump that comes from your customer also has the same problem. Yeah, go ahead and write a script for that. And it will generate reports like this, HTML reports telling you pretty much exactly what's going on in 80% of the cases. And then we have Visual Studio. So Visual Studio has gotten insanely good at reading memory dumps as well, and we'll be looking at how you can use that. So we'll start off with a crash. So if you're lucky, someone comes in and says something like this. Well, maybe you're not so lucky if someone says something like this, but at least if someone gives you an error message like this, you have something to work with. Like you have a repro scenario, and you can probably start figuring out what's going on. But more than often, the person the app is crashing for is like my mom, who comes in with this message saying, "Hey Tess, the internet e-thing is not working anymore." You're going, okay, so does that mean it's not serving pages, or does that mean it's just going away? So then you ask, so Mom, what were you doing? And she's like, I didn't do anything. So if she didn't do it, then who did it? Well, for a crash, particularly, there are only a few different things that could happen that caused a crash. The most common one is unhandled exceptions. So first you have the exception occurs. You have a chance to put it in a try-catch block. If you do that, nothing will happen. But then if you don't do that and you let it just go up the stack, then it will be a second chance exception, and it will crash the process. In cases like ASP.NET, you'll have an unhandled exception handler that will just output like the white screen of death. Or if you do it on a finalizer, it will still crash. But in WPF or in other processes, a second chance will kill your process. And then you have a few other exceptions, like Stack Overflow, out of memory, and fatal execution engine exception that will never go to second chance. And the reason for that is because if you're in a Stack Overflow exception, so if you're in a case where you're in a recursive loop and there is no more stack space to be had, then you can't really have another function handle the exception. So there's no way to handle a Stack Overflow exception. Same thing with an out-of-memory exception. If you're running out of memory, you don't have any memory to do the handling itself. And the execution engine exception is basically when there is a bug in the framework somewhere, so something that causes like a native heap or a .NET heap corruption or something like that. And finally, this might come as a surprise as far as like a crash, but you'll often also see when you have what you think is a crash, it's actually like someone trying to recycle the process due to IIS reset or some recycling mechanism, for example, in ASP.NET. So when you go through a crash, this is, like I put together, is the 1, 2, 3 of what you do, because it's really that simple. First, and you should always do this, check the event viewer. And then capture dump on crash and look at defaulting stack. Crashes are extremely simple in that case, because once you capture the dump on the crash, you will know that whatever caused it was essentially what caused the crash, whatever triggered the dump. It could, of course, be that it is, for example, an out-of-memory exception, in which case you would have to investigate like a memory leak or something. But in most cases, it will be a second chance exception. So we're going to look at that. And we have this app here. It's listing out all the precedents as of right now. This will be old by lunch, but and I got this error report saying that whenever I click next like this, it just stops, like it exits. So what we're going to do is we're going to go ahead and grab a memory dump using proc dump for this. So we'll do proc dump -ma. MA means a mini dump with all options, which is most often what we want. So a mini dump with all options is actually a pretty big dump. And then we say the name of the process, so the precedence.exe, or we can give it a PID if we have multiple called the same thing. And then we say, let's wait for an exception. And I have to start this, so we have something to attach to. And now it's waiting for the crash to occur. So I will reproduce it again. And there we go. So that was how easy it is to gather one of these dumps. So we've already seen this in WinDBG now. If you troubleshoot it, you're going to run ~KB, you're going to run CLR stack, you're going to look at the dump stack objects for DSO. So we're going to look at this instead in debug diag. And this is just the same dump, but pre-prepared. And let debug diag do its default analysis, which is a crash hang analysis. And it will then output this, which is pretty much like without having to know all those commands, you can still get really useful information. Like we had a system argument out of range exception on thread 0. We'll go in and look here. Here is the stack again, and we can go ahead and investigate like the go to another method. And actually, it also says that it had some previous .NET exceptions. So it will list like any exceptions that are actually in the process that might be useful for further troubleshooting. And here again, we have the argument out of range exception. Now I wanted to point out here that it also lists that we have these 3 exceptions that I was talking about, like the out of memory exception, the stack overflow, and the execution engine exception. I want to point this out because this does not mean that these exceptions actually occurred. This means like these are in here always because they can't be generated when they actually occur, so they're created at the startup of the process, so they can just be thrown when needed. Now, there is an even simpler way to look at this issue if you have the symbols lined up with your source code. And the way to do that is by opening the dump file in Visual Studio instead. And it will come up and it will say it was a .NET exception. Here are the modules that you see with LM, by the way. And we can go ahead and click on debug with managed. We can choose debug with managed or debug with mixed if we also want to know the native stacks. But we're going to do debug. Okay, okay, let's do this instead. I think I must have recompiled or something. So I'm going to open up the actual dump that we took. Because if you have everything lined up, it will actually point you to the exact place where it failed. So I think this is super cool. It also gives you like the stack. It gives you the local variables, so you can go in and inspect them just as if you were stopped at a breakpoint. And this is even if the dump was taken on another person's machine, as long as you have the proper symbols that match up with the code. So, check the event viewer. Oh, we didn't do that. So if we would have checked the event viewer, we would have actually seen this, which means that we wouldn't have had to debug at all. But what's the fun in that? So don't check the event viewer. And once you haven't checked the event viewer, then capture, dump, and crash, and look at the faulting stack. Let's go on to performance issues. So performance issues come in the form of like the app is not responding or a request take too long. If you have a request that takes too long, it's very important that before you start troubleshooting that you actually figure out what the actual response time should be so you know when you're done with your investigation. And then it can also be something like the CPU is going haywire. So you might notice in Task Manager that the CPU is going bad. Again, who did it? Well, we have two kinds of performance issues, low CPU and high CPU. So low CPU are when you're waiting for an external resource like a database or a web server or something, or if you're in a deadlock. And then high CPU is if you're in a busy or tight loop, obviously, or if you manage to get high CPU in GC. So something that gets you high CPU in GC will be, for example, allocating a lot of large objects, because if you allocate a lot of large objects, you'll generate, you'll trigger a full garbage collection every time you create a large object. So that means that, for example, if you're concatenating large strings, which are immutable, so you'll create new strings all the time, then you'll easily get into a high CPU and GC issue. And again, how do you fix these? Well, you determine if it's high or low CPU. This is more to target yourself and kind of have an idea of what you're looking for. And then you capture one or more dumps, preferably more, because then you can compare and see, did we actually make any progress between these? Or are we stuck in the same place? Or even if it's a high CPU issue, you might want to see if you're stuck in similar places all the time. So we're going to look at one of these, and we have this one. So I'm going to click on this product, and it takes about 2 seconds for it to stop spinning, or 2.8 seconds for it to stop spinning. So I think that is a bit of an issue, and I want to find out what's going on. So I'm going to use this thing called nettling, which is something I found on GitHub. It's a load tester of sorts. Basically, it spins off a number of threads, and it makes a few requests. So it's a very cheap and easy load tester. Not very sophisticated, but still it's perfect for this. So while we're doing that, we're also going to look in Task Manager to see if it's a high or low CPU issue. And if you can't see this in the back, then I'll basically narrate it for you. So I'm going to run this, and the CPU here is somewhere between 0 and 2% we're looking at the W3 WP process. So very low CPU issue. So we're waiting on an external process probably. So we're going to run that one more time, but this time we're going to grab a memory dump when this is happening. And we can open this up. Again, we could have opened it up in WinDBG, but we're going to open it up instead in debug. Let's see. And run a crash hang analysis to see what's, don't add more files, to see what's going on. And this will now check for a few known issues that like high CPU issues and low CPU issues. And then it will report back and say that we have 8 threads sitting in await. So we're waiting for something else to happen. And then a few threads sitting in garbage collection. And then it gives us a whole lot of other useful stuff. Like it tells us what the threads were that used up most of the CPU. So if this was a CPU-bound issue, you might be looking at what's on thread 20. In this case, it's not, so we see it's been using a minimal amount of CPU, but if it was, this was where you would look for it. And it tells us a bit about the threads, and then it also gives us some information about the HTTP context. So what it actually does here is it just does a dump heap stat or a dump heap empty of all the HTTP contexts, and it then prints out some important information like how long has this been running, and what is the URL and so on, and what thread is it running on. So this seems like one of the culprits because it's been running for 2 seconds, still running, and we want to look at thread 28 to see what's going on. And here we get the call stack, but we also get information like 8 threads are running the exact same stack, which means that obviously that is an issue that we need to investigate. But here we get the call stack again, and we see products controller, so we did slash products. That calls into data service get all products, and that sits in await. So it's time to go in and look at the code and investigate. Or if we want to take it one step further, we can go in and open it in WinDBG. So let's see. I'll grab it from here. And again, I can do managed or mixed. I'll do mixed just for fun. But this time, it doesn't stop it and show us the code. And the reason for this is because there was no active thread when this was taken, because we didn't get it on a crash. So we didn't get it on something that actually triggered a dump. We just took a dump as is. So what we can do then is, because we're interested in looking at the stacks of all the threads, so we'll go in debug windows and parallel stacks. This is something that you can use even when you're normally debugging. It doesn't have to be from a memory dump. And it will then tell us that 8 threads are sitting in this get all products and sitting in await. And if I actually click on this, it will take me exactly to the line that has the issue. So very powerful stuff, right? Sometimes, though, let's see, we'll go back to this first. So determine if it's a high or low CPU, capture one or more dumps, look at all the threads and what they are doing, and basically go from there. But sometimes you can't capture it closely enough because it's such a small performance issue. But if you can repro it and test in that case, you can use profiling instead. So we're going to look at one of those issues. And it's going to be in the precedents app again. Let's see, I just want to make sure that I shut this down because otherwise I'm holding on to the symbols. So what we're going to do is we're going to troubleshoot an issue that goes something like this. When I click next, you see sometimes it kind of stops on the, like it doesn't move forward for a little while. So we want to figure out what is causing that delay. And the way to do this is to go into the Analyze Performance Profiler window in Visual Studio. It has a lot of different profilers. And specifically for this issue, we're going to use a performance wizard. So here we can actually go in and profile anything. We can profile a running or installed app that we don't necessarily need to own it, but if we own it and have the symbols and source, we're going to get a lot better results. But we can profile ASP.NET apps too here, and you don't actually have to launch them from here. So we're going to start up, and you get a few options for how you want to profile. In this case, we have a low CPU profile, a low CPU performance issue, but you have CPU sampling or instrumentation for performance issues. So CPU sampling, what it does is it goes in from time to time and slices and to see what's on the stack, what's on the stack, what's on the stack, what's on the stack, and based on that, it determines how much time you're spending on the CPU. The instrumentation one injects like a call before, like every time you make a call, it injects a marker. You called it, you exited, you called it, you exited. And that way we can get what we call elapsed time. So not CPU time, but the actual clock time of the of what's going on. So we're going to run this. And once it launches, we'll just reproduce the issue a little bit. And then we're going to stop profiling. I profiled this a number of times, as you can see. And then it tells us essentially what it thinks the problem is. So let me see, because it looks a little bit different than it used to. It gives me a bit more information than I actually wanted to. Let's go in and look at this anyway. So we spend most of our time we spend pretty much all of our time in main, because that's obviously just running the process. And out of that, we spend 57%. Can you see this in the back? A little bit, yeah. 57% we spend in next button click. And that's actually the time we're interested in, because that's where the issue happens. Out of that time, pretty much all of that, like all 57 something, is in this go to another function. And you can see how my code down here actually follows along when I click on that. Out of that, we spend most of our time in this setter for this property, and in the raise property changed, and in the invoke. And then we come into something that looks a little bit weird, but if you're doing WPF or UWP, you know that's like it's a value converter. So you have something in your view model, and then you want to display it in SAML, so you use a converter. So in this case, it was I took the precedence party and converted it to a color display. And then most of that time was spent in get color, and then most of the time was spent in await. So most of the time was spent here. And now we've been able to narrow down and find out the exact source of this performance issue in just a matter of minutes. So use profiling if you have issues that you don't feel like that are large enough for you to actually go in and do a dump on. Okay, so the last type of issue, memory leaks. Same thing there. You might see out-of-memory exceptions, slow response times due to GC activity if you have a lot of allocations and such. And you might also see something like the memory increase in Task Manager. That's usually the most common reason that you go in and try to troubleshoot a .NET memory leak. So you might think that since we're running with the garbage collector, like the memory should automatically be garbage collected, and that is true, except for it will only garbage collect whatever you tell it to garbage collect, or rather whatever you don't tell it to not garbage collect. So a few things that it won't garbage collect, obviously, is things that are in cache or session state. If you told it to cache it, or if you told it to keep it in session state, it doesn't collect it until it's supposed to go out there. Or if you have a static or pinned object, or if you block your finalizer. And you could also have issues like assembly leaks. So some constructs in .NET, like regular expressions or the XML serializer, which I don't think a lot of people use anymore, but those will generate dynamic assemblies. So be careful and look at if you have, like with LM, you'll see if you have a lot of assemblies in there. And then it might be a native leak, and in that case, you want to do leak tracking with debug diag. But again, pretty simple three-step process. You can capture mini dumps, capture multiple dumps, and the reason why you want to capture multiple dumps is because then you have a better chance of comparing two dumps and seeing what it is that you leaked. So one, for example, when you start the process, one when you leaked a little bit, and one when you leaked a little bit more. And then you compare with dump heap stat, for example, to see what objects you're leaking. So basically where the number is growing the most. And then you use GC root to figure out why they are still around. So again, a fairly simple process. And then for native leaks, use leak tracking in debug diag. So in this case, I'm actually going to go in first with WinDBG, or not with WinDBG, with Visual Studio. And I'm going to open up a memory leak dump that I've generated before. It's 1.4 gigs of addressable memory, so probably around 700 or 800 megs of actual memory it's using. So I'm going to open that up. And there is an option here to debug managed memory. So what this will do is it will take a look at the memory dump, and it will look at all the objects, enumerate them with dump heap stat and, equivalents, and then it will look at all the roots. So it will look at all the statics, all the pins, all the threads, anything that could be holding on to an object, and it will generate graphs for those. This is actually something that you can do when you're step-by-step debugging too. If you're opening up the diagnostics window in Visual Studio, there is a take snapshot, and you can take a snapshot of the managed heap, and you can look at the heap like this. So I'm actually going to go ahead and insert another memory dump that is my base memory dump. So this was the one that was taken before the memory leak occurred. And then I can go in here and I can sort by inclusive size. So this is like taking object size, so the size including all the sub-objects, and say, okay, so it seems like this news controller, so when someone went to /news, we're leaking 31,000 of those, and that's taking up a total of like 368 megs of memory. So that's definitely an interesting character. And we can also see that we're leaking like a similar amount of HTTP context or response or request. So probably what's going to happen is if we fix the one leak, we're going to fix the other ones too, because they're kind of members of one another, so to speak. So then Visual Studio will give us this neat little thing, which is GC root, the visual version, that tells us that this news controller, like 31,000 of them, is held in like this view data recovery. I don't know what that is. But this thing I do recognize, like a cache item removed callback. So what this is like by now you start like Googling, okay, cache item removed callback if you don't recognize what that is, and you'll figure out what's going on. But what is happening right here is this. I'm caching something, and then I'm saying when the cache is removed, like when this item is removed from cache, go ahead and call this function because I want to clean up some stuff. And this function belongs to the news controller. And since we're using an instance function rather than a static function, this news controller has to be around as long as that other object is cached, which is why we're leaking the news controller. So the answer here would be to use a static function, but what I really wanted to show is just like how you find the roots. The roots are kind of irrelevant because the issue will always look the same independently of what the roots are. You can also go in and troubleshoot this in debug diag, and we'll go ahead and let's see demo dumps and the leak, because sometimes you might want just a little bit more information and you don't remember all the commands and everything. So in that case, I always run with debug diag just because in case I forgot something, then debug diag usually always picks something new up that I can use as a clue. It takes a little bit longer for debug diag to troubleshoot one of these because it was so big. And I have to click this for a number of times. Okay, so it has different things that it displays in the like hang and crash analysis case versus the memory case. So in the memory case, it will tell us how many things are ready for finalization. If you have a lot of these, you might have a blocked finalizer, but it gives you like a whole set of links to what is this issue about, like how should I be troubleshooting this. Most of these links happen to go to my blog, but that's mainly because I wrote these scripts, but they can be useful information anyways. And then we have information about how big the .NET heap was, in case you missed that. And it does a few other things, like display the objects, like the dump heap results in a more visual way. And it also colorizes. You might not be able to see this in the back, but this news controller is actually purple, and that's because it found that to be a custom object, so something that's not in system web or in some Microsoft namespace. So that's just there to visually tell you that this might be something that you're looking for, because it's not common that custom objects show up this high in the stack or high in the heap. And then it shows you the finalizer. In this case, the finalizer is not blocked. It's just waiting for a finalizer event. And it will also display like everything that's in cache. So in this case, we can see that we stored a whole lot in cache, which is also part of the memory leak. But it gives a lot of useful information. And all of the debug diag scripts have like a table of contents like this, so you can switch back and forth. So let's see here. So capture multiple DOMs, compare to see what they're leaking, and find out why the objects are still around. So with all of these three issues, you've seen we can do this in WinDBG if we want to really fine-grain control and want to dump out individual objects, or we can do this in debug diag if we want a quick, easy, what do you think it is? And in 80% of the cases, it will be fine. And if we have symbols and everything, we can go the route of Visual Studio. Even with the heap thing, you don't actually have to have any symbols and anything for the heap thing to work. So let's see. So once you've started doing this for a long time, then you start getting into wanting to actually automate things. And you start doing this pretty fast if you start doing a lot of dump debugging, and specifically if you try to recognize the same issue over and over and over. So I just wanted to tell you about something that has come out recently that's pretty cool, and that's something called CLRMD. So this is a NuGet package that you can download. It's still in like an unstable version or whatever it's called. It's like if you go to NuGet, you have to don't only install the stable DL. So, but you can download this, and then you can do things like this. So you can either load up a crash dump in your process, so you can reiterate over X amount of dumps that you have stored in like some dump container, or you can attach to another process if you want to. You can attach live to a process. And you load up symbols. So symbols is essentially what translates from addresses to function names. And msdl.microsoft.com, it's not misspelled, it's supposed to be an L. /download/symbols is where you get all the Microsoft symbols from. And then you create a runtime, and from here you can get to things like how many heaps did we have, how many threads did we have, and that kind of stuff. Or you can go in and iterate over all the threads and find out, was there an exception on the thread? And if there was an exception, print out the thread number and print out the exception message and name, and then print out like all the stacks. Or you could do something like enumerate all the objects on the heap and just dump out your specific configuration object that might have some important information that you want to know if this customer had this configuration set or not. And in that case, you can do that. So there's loads of stuff that you can do with this that are not necessarily even dump debugging, but is finding out quick information to know if the issue that you're troubleshooting has certain criteria. So it looks like this. I hope this will work now, because we saw these symbols were kind of off, but let's do this. Okay, so yeah, in this case, it just brought up that first dump that we were looking at, found that one thread had an argument out of range exception, and this is the stack for it. So pretty easy to use, and you can do anything that you can do pretty much in WinDBG that I showed earlier, you can do with CLRMD too. So with that, I'm going to leave like the last minute for questions, and then I'll be out here too afterwards. Yes? Is it possible to use some of the strikes with core CLR? Is it possible to use Son of Strike with core CLR? No, because it's not, like there isn't a Son of Strike compiled with Core CLR, but I was talking to, and I'm not sure if Sasha is here today, but I was talking to Sasha, who's doing a lot of stuff with the CLRMD, for example, and he was saying that a lot of people have recompiled SOS, and then you can use it with Core CLR. So in that case, you would have to recompile it yourself. But there is no compiled version that comes with the CLR quite yet.
And also, is Microsoft doing some tools to, like, WinDBG for Linux?
So the other question is Microsoft doing some tools like WinDBG for Linux? And the answer is, I don't know. But again, Sasha was talking about that too, because he's been doing a lot on debugging with the Core CLR. And he was saying that you can get some debugging working like that, but you have to kind of compile everything yourself. It's like back to the old Linux days when. So sorry about that answer, but.
Can you recommend any good resources for people who want to learn this stuff?
Yes. So can I recommend any good resources for learning this stuff? Yes, my blog. And I say that kind of, but I'm one of the few people who have actually delved into writing a lot of stuff about this. So it's blogs.msdn.microsoft.com/Tess. You search for my name, or go to my Twitter handle, and there is a link to the blog. Or if you debug anything with debug diag, you'll get to my blog. And I have a lot of debug labs. They're pretty old by this stage, but they still work and they still show how you do things. So I have labs for pretty much all of these issues. And I'm going to be updating and putting this, plus the demos I'm going to be using. I'm going to write a blog after this and put this on there. So thank you for that question. That was great.
Is there a way to automate the debug diag analysis thing?
Is there a way to automate the debug diag analysis thing from the command line? I do not know, but if you find, I'm going to give you a name, Wade Mascia, that's Mascia. He's on the internet, and he's the one who's actually maintaining debug diag right now, and he was the one who actually wrote from the beginning. He would know definitely for sure. And if there isn't a way, because I haven't used it like that, I've automated CDB and stuff like that, but not debug diag itself. But if there isn't a way, he might be interested in making sure there's a way. Okay, thank you guys.